Micrometer Screw Gauge. It is a measurement device. We will discuss what is micrometer and how we can measure any object. When we want to take diameter measurement, external dia or internal diameter, most of the time we use vernier's caliper. Here it is showing external diameter. If I want to measure internal diameter, we will use this side. When we want to take extremely precise measurements, we use micrometer. Now we will understand one thing. Micrometer. Micrometer, it is a measurement unit that is known as micron. That is 1/1,000,000th part. 1 × 10⁻⁻⁶. That is measurement unit, micrometer or micron. But this is measurement device. It can measure any object from 0 to 25 millimeter. That means 2.5 centimeter. That is maximum range for measurement. What is the accuracy? What is the measurement steps? That is 0.01 millimeter. 0.01 mm. If we convert into micrometer, 0.01 multiplied by 1000, that is 10 micrometer, 10 micron, or 10⁻⁻⁶ meter. 10/1,000,000. If we divide 1 meter into 1,000,000 parts, so minimum steps, it will measure 10 micrometers, 10 micron. It is very sensitive device. When we are using it, we need to take very special care. C frame or U frame, it is used to hold this device, this measurement tool. We will hold from here. In this frame, there are two measurement surfaces. One is static, second is movable. Static surface is called anvil. That is this one. And here are faces. Anvil face, this is moving part. This moving part, it is called spindle. Spindle surface, anvil surface. This spindle is also called screw. This one, ratchet. This moving cylinder, it is called thimble. And this grip, it is called knurled grip. This static part that has marking, that is called sleeve. Sleeve has two types of marking. One line. This line on the sleeve is called index line, reference line. Marking above the index line is called main scale. Below the index line, that is called vernier scale. Marking on this cylinder, it is called circular scale. It is very sensitive measurement tool. For measurement, for its long life, we must take care for its safety. Here is a lock nut. When we want to take measurement, we open its measurement surfaces from here. It is opening this gap. We will place any object here for measurement, and then we will tighten it. Then we will check measurement from this scale. Some micrometers have zero adjustment screw in this portion, but this one don't have here. We can make zero adjustment from here. If we rotate in this direction and it is touching to anything, any object, it will start a ratchet action. It will click. It will not move the screw furthermore. So it will indicate that there is some obstruction, there is some object here, or it is reached at its maximum limit. If you check its marking system, 3 different types of marking there. Here is index line, that is on the sleeve. In upside, 0, 1, 2, 3, 4, 5, 6, 7, it is main scale up to 25. This is the maximum limit here now, 25. Now its spindle is in full retracted position, so that is its maximum limit, 25. The upper cut lines will indicate 1 millimeter from 0 to 1. And if we see the bottom side, here is also marking. It is called vernier scale. From here to here 1, and it is half. We can say 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. Main scale, then vernier scale, and third scale is this rotary scale, that is circular scale. When we want to hold it, we will hold in this direction from here. We will not hold from here or any other place. This lock nut must be unlocked and now this circular scale is moving. When it will touch to its maximum limit, but if we see, this 0 is slightly away from this index line, so it is 0 error. It is showing approximately 0.5 when the spindle is touching to anvil. This error must be zeroed. Here is key, adjustment key. We will place this key in this cut and now we will adjust to align the 0 line with index. If it stops at any other point, for example it is stopping here, that means it is counting, it is measuring +1 when the spindle is touching to anvil. That will error. So we will note that error, that it is measuring 1, circular 1. When we will take measurement, we will subtract this 1, or if it is measuring -1, that error will be added. In our condition, now it is 0. Now I will rotate this scale 5, 10, 15, 20, 25, 30, 40, 45, 46, 47, 48, 49 and then 50. When we reached again at 0, the vernier scale, the lower scale is now visible. Now 2 scales are visible, 0 and this scale. So 0.5, we can say when it will take one circle, 0.5 millimeter will be covered. Now any object here, that will 0.5 millimeter. This scale, main scale, 0.0, that is below this index line. And in circular scale, from 0.00 to 0.49 or 0.50, 50 steps. For example, here If our spindle stops here, 0 is now visible. We will write 0 point below index line. There is no vernier scale, so we will write 0, and then we will write the number that is visible on this circular scale that is touching to index line until here 40.40. Now we will add these units. 0.40 millimeter. For example, there is one other condition. If our measurement stops here, between these two lines, we can assume that it is 0.5. So we will write 405. That is half. So this measurement was 0.4 into 1400 micron, and this one 0.405 1000. Now 405 micron. If our measurement stops between two cuttings, that will be assumed and that will be added next to 40. Now let's take measurement of this wire. Check ratchet sound. Then we will check 0. That circular scale is touching to index scale. That means it is 0. There is no error. Open it. The measurement object must be straight and clean. If our measurement object has bends or some dust, rust, corrosion, that time we cannot take exact perfect measurement. Now we will rotate it and we will listen the ratchet sound, the click sound. Yes, now spindle is touching to the measurement object. We will lock it here. Now let's check measurement. 0 is visible, and first cut here that is visible below the index line. This is 0.5. First cut will indicate 0.5, and then this 0 is here, and next 1, 0.01. So our measurement is 0.51 millimeter. If you want to convert to micron, multiply with 1510 micron. If we check here, the printed number 0.5 millimeter. Unlock, open it. Let's check diameter for this cover. The ratchet is now giving click sound. We will lock it so that our measurement will not disturb. Now we can see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 point. Next to 9, this vernier is now visible. 9.5. 0.5. And now we will check this circular scale. 35, 36, 37. 37. And after 37, it is crossed half line. It is now in center. So we will write 5. If it is touching to this main line with index, that will 37, but now it is between 37 and 38. So we will write 375. Measurement 5, 7, 8, 9. 9.875 millimeter. Yes, it is showing 9.87 millimeter. And our measurement is 9.87. If this video is informative for you, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.